I've paid my dues, time after time. I've done my sentence, but committed no crime. And bad mistakes, I've made a few. I've had my share of bad kicks in my bed, but I've come through. I need to go on, on. We are the champions, my friends, and we'll keep on fighting till the end. We are And I mean right en mi cuerpo. Nadie me vio partir, lo sé, nadie me espera. Hay una grieta en mi corazón, un planeta con desilusión.
Donc l'idée, ça sera de démarrer un petit peu. Donc j'explique la situation concernant les membres du jury. Donc vous avez décidé d'un président de jury, mais en fait il n'y a pas trop le choix parce qu'on avait pensé à Pierre Neveu, mais Pierre ne peut pas être président de jury parce qu'il est en distanciel et selon les règles de l'ED, c'est pas acceptable. Donc le président de jury sera Alejandro. Tu es d'accord, Alejandro?
Oui, je suis d'accord.
Voilà, donc évidemment il faut l'avis de tous les membres du jury. Moi j'ai pas à m'exprimer bien sûr, ni David, mais vous avez
Ay, ¿qué pasó?
dire si vous êtes ok ou pas, et si vous êtes pas ok en fait
Je suis d'accord. C'est votre tour, c'est votre tour. Voilà, on vote tous pour.
ok, voilà.
Merci tout le monde.
Et donc Alejandro a un timing un peu spécial parce que pendant la présentation de Daniel, enfin tu vas pouvoir expliquer Alejandro, mais tu Freddy Ordonez d'Équateur.
Voilà. Alors, tous les jours, il est là. Bon. C'est-à-dire qu'on commence...
Pierre est là?
Pierre est là.
Oui, je suis là, moi.
Ah, je sais pas, je te vois pas.
Y falta que ingresen a un profesor de posgrado.
Je te vois.
No me acuerdo, pero un extranjero, porque yo tenía lista el alta y me di cuenta que faltaban, agregué los integrantes que no estaban ingresados, pero hay un profesor que no está en el sistema ingresado, no lo ingresaron. Entonces, como yo mando el currículum del pasaporte, ellos tienen que ingresar cada uno de estos cuando no están registrados.
Pero si sale antes de...
Ya, y si no lo dejo con la amarilla, está bien, porque me dan ese interrumpir.
Eso, mira, nosotros vamos a hacer de 9 a 10 más o menos la sesión, después viene de 10 a 11.
A las 10 voy a estar acá con el alta, ¿te parece?
Súper.
Ya, yo lo
Sí.
traigo
Y
entonces.
te asumo y yo salgo.
Ok, súper bien.
C'est bon, alors on est...
Tu veux lancer, Alejandro? C'est à
Oui,
toi de...
voici, on est prêt pour commencer, alors comme vous
Ok,
disiez.
bonjour à tous, à toutes. Bienvenue à cette conférence de thèse doctorat. Comme Didier a expliqué, je vais être dans le site dans 15 minutes. Et donc, on commence la soutenance avec la présentation de Daniel. Daniel a 40 minutes pour la présentation. Et après, c'est la partie de questions. Donc allez-y, Daniel.
So you can go in English. The presentation was in French, but you can go in English.
Ah, okay. Now,
Yes, now you can. I will translate what Alejandro said. You can start. You have 45 minutes.
okay. Okay, hello everyone. I am Daniel, and today I will present my doctoral thesis titled Contribution to Optimization in Energy from Bi-Level Optimization to Optimal Design of Renewable Energy Plant. This work was supervised by Didier Ocel, Héctor Ramírez, David Salas, with the collaboration of José Cardemil, Nicolás Hernández, and Nathalie Macet. Also, this work was in co-tutelle between University of Chile and University of Perpignan via Domitio. Okay, so when we talk about optimal design of energy units, such as delivery plants, production plants, like electric vehicle charging station or renewable energy plants, we can understand this problem in many ways. For example, one problem could be determining the best physical characteristic for energy units, or determining the best way to operate energy units, and also determining the best optimal location to build an energy unit. Okay, so in this work, we will address the aforementioned cases where in the first part, motivated by the determination of optimal location of electric vehicle charging station, we will focus on bi-level optimization problem with cardinality constraint. For the second part, we will work on optimal design of concentrated solar power plants in the context of electricity market prices and its optimal long-term operation. So there is a second section in this part where we wanted to address the optimal operation of a concentrated solar power plant, considering perturbation in the solar irradiation. So this last part was analyzed in short term. Okay, and finally, I will present the main conclusion and perspective about this work. Okay, for the first part, it's necessary to know the following. What is a bi-level optimization problem? So you can see this concept like we have one optimization problem, and inside of this one, we have another one. So for the first one, we refer like upper level problem or leader problem. And the other one, we refer like a lower level problem of a lower problem. So here we have that capital F and lowercase f, the objective function for each problem. X and Y are the variables, but it's necessary to know that for this kind of problem, the variable X is a parameter for the follower problem, okay? Okay, so we will work with generalized Nash equilibrium problem. So this kind of problem consists in several players solving each one a parametric optimization problem. So I mean, you can see this problem. So here, the player is I, is the variable, but the rest of the variable are parameters for this problem. Okay. And here we have a one optimization problem with cardinality constraint. So we refer, we denote this zero norm like the number of non-zero elements in the vector X. So this optimization problem with this additional constraint add more complexity for this kind of problem. Okay. So therefore, in this first part, we will work with bilevel optimization problem with cardinality constraint. But we will address this problem for this particular case when we have single leader multi-follower game. Single leader because we have just one leader problem and we have several followers problem. And here we have the cardinality constraint, and Gnet is the set of all solutions of the generalized equilibrium problem. Okay, the variable X is a parameter for this set. Okay, so we will address the following cases. So the first one is when we have a bilevel optimization problem with cardinality constraint at the upper level, like appear in this slide, right? Because the cardinality constraint is in the leader problem. The case 2 is when we have cardinality constraint at the lower level, and the third case is when we have a mixed cardinality constraint. In this case, we will have this cardinality constraint in both levels, but later I will explain better this part. But for this presentation, we will focus just in case 1 and case 2. For case 2, what we did with it appear in this manuscript, and this case has a pathological behavior. Okay. Okay. So for the first case, we begin by demonstrating the existence of solution for this kind of problem. So to do that, we followed the paper where Didier and Anton Svensson, they demonstrated the existing solution of single leader multi-follower game. So the hypotheses for this theorem are the following. For example, capital F is lower semi-continuous and capital X is compact. For each follower problem, we have that the objective function are continuous. The graph of capital Y are uniformly bounded, and the set value math of capital Y is lower semi-continuous with non-empty closed graph. So the principal idea to prove these results is to demonstrate that the set F is compact. Okay, so we will have that is F is either empty or compact. Okay, then we did this reformulation when we wrote this zero norm in an equivalent way. This equivalent way is these three expressions. So to do that, this expression appear in this paper where they propose this reformulation, but for one-level optimization problem. Okay, so with this reformulation, we demonstrated the equivalence between this problem and the original problem in the sense of global solution. Okay, okay, then we did a second reformulation. Okay. Okay. Then for this, then we did a second reformulation. So for that, we replace each follower problem with each KKT, each parametric KKT condition. So at the end, we will have a mathematical programming with a complementary constraint, okay, as you can see in this slide. So with this last reformulation, we demonstrated the equivalence between the three previous problems, the original problem, reformulation 1, and reformulation 2. So to do that, we have some extra assumption on the lower level problem. Okay, for the case 3, we took these three expressions and we distributed this expression in both levels. So as you can see here, so why this distribution? Because, for example, when we have the case 2, these three expressions will be in each follower problem, but the dependence of variable u will be in each problem, so we will have that the feasible set of each follower problem will be not convex. So one solution to address this thing is to take this expression and to put in the leader problem. But the dependence of variable u will be in the leader problem too. In that way, this expression will be linear. So that's it. We demonstrated the existence of solution for this problem. And also we did a MPCC reformulation for this problem. So the last result is that we can, the equivalence between these both problems, this one and the MPCC reformulation problem in the sense of global solution. Okay, so with the idea to illustrate the previous concept and results, we will have a look facility location problem. So this problem consists in to determine which facilities it's necessary to build according to the preferences of the drivers and the capacity constraint in each facility. I mean, we will have that for example, we will have one facility with will have a maximum of capacity to serve per day. For example, just 100 drivers per day, something like that. Okay, so you can see this problem like the company of electrical charging station will be the leader problem, and drivers will be the followers. Okay. Okay, here we have this table with the description of parameters and variables for this problem, where the variables are x, that indicates whether facility S is built or no, and y, that represents the probability of driver I going to facility S. Okay, and the rest of parameters parameters are representing the cost, the maximum capacity per day, congestion factor, etc. Okay, so for this problem, we will consider two different objective functions. The idea is to maximize the profit and maximize social welfare. Okay. So remember that for these bi-level optimization problems, we focus in upper structure when we have cardinality constraint at the upper level and mixed structure. Okay. So we will have 4 different problems when we have the structure, upper structure, with maximizing profit and maximizing social welfare, and the same for mixed structure. Okay. Okay, so for this simulation, we consider 150 cars and 3 different facilities. So practically we will have a cheap facility, medium facility, and an expensive facility. And these are the maximum capacity to serve per day for each facility. Okay. So we will have some parameters like alpha and p. So this parameter will be randomly generated. Okay. So for each case that I will show you, we will have different values. So here we have the numerical results. So you can see that for the upper structure, we have some cases where we didn't find any feasible point, but for the mixed structure, always we find one optimal solution. So for mixed profit, the solution is the same in all cases, but for mixed social welfare, we have different solutions. For example, the first one, we found that it's necessary to build 2 medium facilities and just 1 expensive facility. And here in this table, we have the distribution of this driver in each facility. Okay. So for example, for this case, we have that it was necessary to build 1 facility of each one. Okay. Okay, so one reason that why it was not possible to find a feasible point is that we used a limit time to find a point, but this limit was equal to 1 hour. So maybe it's necessary more than 1 hour to find this feasible point. So in this graph, we can see that for the upper structure, I mean red and blue points, to find a feasible point, in most of cases, it was necessary around of 1 hour. And the optimality gap also were high in all of these cases. But it was not the case for mixed structure, where we have a good optimality gap and the execution time was low. Okay. Okay. Okay, so for the second part, we will focus on electricity in concentrated solar power plant. As you can see here in this picture, this is the name of this plant is Cerro Dominador, that is in the north of Chile. So this square that you can see here are mirrors, and the function is to concentrate the solar irradiation at the top of this tower. So then we'll pass a heat transfer fluid receiving this heat, and finally it will be transferred in electrical energy. Okay. Okay, so with this construction of this plant, it's possible to prevent the emission of approximately 600 143,000 tons of CO2 per year. So this plant is part of one project in Chile to reduce the dependence of fossil sources. Okay, so for the moment, this kind of plant is with subsidies of government. So the idea with this study is to see to what extent a CSP plant can have economic equilibrium without these subsidies. So how to do that? Through electricity market. Okay, so this kind of plan can be divided in 3 components. The first one is solar field. The second one is a storage system. And the last one is power block or Rankine cycle component. Okay. So in this point, it's necessary to say that the economical success of this kind of plant depends of the storage system. So you can imagine that they make no sense. It doesn't make sense to build one plant just to produce electrical energy during the day. Okay. Okay. So the objective in this part is the first one. Imagine that we have a project of plant. So we want to know what would be the best dimension for this plant. So the idea is to decide what would be the best technology and dimension for the storage system. Okay. And after to build a CSP plant with optimal dimension, the idea is to know what would be the best way to operate this plant. So we have some techniques that we can detect the peaks in the price of the electricity market, so we can reach some economic equilibrium. Okay. So with this objective, we want to improve the economical efficiency of the CSP plant. So for this part, we will have, or we will consider the electricity market prices. Okay. 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 In this point, it's necessary to say that we will fix 2 components: the Rankine cycle and the solar field. And for the storage system, we will consider different variables. For example, variables that represent the dimension for this storage system, variables that represent the operation for this storage system. Okay, with respect to the modeling for each component, for the Rankine cycle, we use some polynomial regression. The idea is to simplify the operation of this component. So at the end, we obtained a regression like this one. So in this case, with this regression, we can determine the electric power knowing the mass flow with respect to the heat transfer fluid, temperature inlet for this component, and temperature with respect to the environment. Okay, so for the solar field, we use the software Sun. With this software, it's possible to generate some points with respect to the solar irradiation. So with these points, we can define a useful thermal power function. Okay, so this function will represent the heat ready to the thermal power entering to the plant, ready to store energy or to produce electrical energy. And finally, for the storage system, we will consider 2 different storage systems. The first one is the thermochemical reactor system, and the second one, 2 tanks indirect storage system. Okay, so to address the previous objective, it's necessary to define an optimal control problem. So here you can see a general structure of this kind of problem, where in the objective function we have the economical indicator, and here we have the three different variables for this problem. The first one, nu, is representing the physical dimension for the storage system. Mu will represent the operation for the storage system, and tau, that is the strategy variable, will represent the different phases that this plan will be over horizon time. Because for this model, we are considering 4 different phases. The first one is inactive phase, storage phase, production phase, and discharge phase. When I say discharge phase, is when the plant is using the stored energy to produce electrical energy. Okay. Also, one assumption in this model is that the transition between one phase to another phase is instantaneously. Okay. But really, to solve this kind of problem is very hard. So for that, we use this concept called pre-scenario. So with this pre-scenario, you can transform an optimal control problem in a classical optimization problem. So this concept consists in this context, fix the number and the order of the different phases. For example, here you can see one example for one day where we fix the order and the number of phases. I mean, just one storage phase, just one production phase, and here we have just 2 discharge phases. Okay? Okay, so now we build a meta model which allow us to consider different technologies and parameters for the CSP plan. In that way, we can define different optimization problems for the CSP plan. So, for example, one optimization problem would be a CSP plan with this storage system, thermochemical reactor system, this economical criteria, net present value, and this production strategy that is price chasing strategy. So this strategy consists in discharge energy in highest prices, okay? And we will have this another production strategy that is classic strategy. So the idea is to discharge energy after sunset, and just one discharge phase, and the duration for this discharge phase is fixed. Okay. Okay. So here we have the one result that we found. So these results correspond to this configuration. I mean, one CSP plan with thermochemical reactor system using this economic criteria, net present value, and using this production strategy, price chasing. Okay, so in the first graph, you can see the optimal operation for this CSP plan for 1 week. So here we can see the different phases, and below we have the price curve. So you can see that the price chasing consists in discharge energy when we have a peak in this price curve. So for that reason, we have this green rectangle over this peak. So here we have another green rectangle because here we have another peak. Okay. So it's necessary to say that behind of this optimal profile for this plant, we have an optimal dimension for the thermochemical storage system. Okay. So here I want to present you some results about our comparative study. In this case, we have the classical production strategy in both cases. And here we are varying the duration for this discharge phase. Remember that for classical strategy, we have just one discharge phase and the duration is fixed. So here we are varying the duration for that discharge. So in this case, we have different economical criteria, net present value and levelized cost of energy, and different storage systems. So in both cases, we found that the best configuration corresponds to a CSP plant with 2 tanks storage system. Okay? So now we consider another economic criteria that is conventional payback. So with this criteria, the idea is to know how many years are necessary to recover the investment. So according to our results, it's necessary around of 27 years to recover the investment. But also, you can see a big difference between 2 tanks storage system and a thermochemical reactor system when we are using a classical strategy. But now, for this comparative study, we are using different production strategies. So, for example, this discontinuous red line corresponds to a thermochemical reactor system, and green and black line correspond to 2 tanks storage system. So you can see that it was possible to reduce this difference at the moment when we change the production strategy. So another important comment for this comparative study is that according to the literature, it's not possible to reach an economical equilibrium without subsidies of government. So according to our results, it is possible. So around of 27 years, okay? Okay, so for the second section, for this part, the idea is to explore this optimal operation for a CSP plant, considering perturbation on the solar irradiation. So what is the problem here? For example, when we have a sunny day, we have a curve like you can see here. Yeah, we have a useful thermal power function as you can see here. Okay, but in a cloudy day, that curve could be like this red curve. So these variations can affect the plant or can affect the production of electrical energy. So then this variation will affect the distribution network, okay? So one solution in this kind of critical scenarios is, for example, to turn off the power block or Rankine cycle. So because it's possible that it's more expensive to produce electrical energy with low heat, okay? Okay, so for this second section, the idea is to address the following problem: to maximize the profitability of the CSP plant by maintaining electricity production with low variability, considering critical scenarios with respect to the solar irradiation curve. So to do that, we built this differential model where we have the same components. We have solar field, storage system, and Rankine cycle. But also we will have these pumps. The idea with these pumps is to control the heat transfer fluid throughout this plant. And here we have another circuit because for this model, we will consider that it's possible to turn off the Rankine cycle. So at the moment when we have the Rankine cycle off, the heat transfer fluid will pass by this for this circuit. Okay. Okay. So here we have the different equations. The first two equations are representing the variation of the masses in each tank, hot tank and cold tank. Hot tank and cold tank. And the two last equations are representing the variation of temperatures in node 2 and 4. Node 2 and 4. Okay? So for this model, we consider switch control variables, as you can see here, because with this switch control, it's possible to change the dynamic when we have, for example, the Rankine cycle off or on. Okay. Okay. So for this exploratory work, the idea was to find the optimal shutdown for this component. So to do that, we will fix the switch control variable. So for that reason, we will have a delta time. This delta time will shift over all horizon time. Okay. So for this work, we will consider just one shutdown for this study. Okay, so here we have the useful thermal power function. Here you can see the two perturbations, the first one and the second one. And here we have the price curve. So these functions are exogenous for our model. Okay, here we have the numerical results that we found. So here you can see the different delta time that we consider. For example, when we have this delta time equal to 20 minutes, 30 minutes, etc. For this first case, we don't have a shutdown over all horizon time. Okay, according to these results, the optimal shutdown will be at 8 hours and 50 minutes with a duration equal to 30 minutes. Okay, so here we can see the variation of the masses in cold tank and hot tank. And here we have the shutdown. Okay, so here you can see the production of electrical energy. So we can see that we don't have a strong variability of this production in all horizon time. That's it. Okay, so the main conclusion for this work, for the first part, we demonstrated the system and equivalence between the single leader multi-follower gain with cardinality constraint at the upper level and mixed level. And also, for the facility location problem, we found that in all cases, because we did 50 different experiments, in all cases, the mixed structure showed a better behavior with respect to find a solution for this kind of problem. One perspective for this part is to consider multi-leader, multi-follower gain. So in that case, we will have different leader problems. So you can see this structure like we will have different components and different followers like drivers, etc. And the idea is to aggregate more details for the facility location problem. For example, considering different batteries for each electrical car, something like that. Okay. The work with respect to this part is submitted in Jota. Okay, for the part 2, we found that in most of cases, the best configuration correspond to consider a CSP plant with 2 tanks storage system. But remember that when we change the economical indicator, we found that the results with respect to the thermochemical storage system was good. So also for this part, we found that it's possible to reach the economical equilibrium in a few years, like 70 years. And a possible work in the future is to consider different strategy to store energy. For example, to store energy in low. So with this different strategy, we can produce, for example, store energy during the summer and to discharge energy during the winter. So it's an example. And for the last part, we could build a simple model. So with this model, we can have important information with respect to temperatures, thermal power, and mass flow around throughout of this plant. So with this model in the future will be possible to address problems considering stochastic variables. So the idea is to have a more realistic scenario when we have a stochastic perturbation on the solar irradiation curve. That's it. Thank you so much for your attention. Any question?
Okay, David, is Alejandro back?
Not yet.
Okay, so just waiting for him. We can start the question session. Perhaps I will take the liberty to initiate. And classically, we ask for the referees to start the process. So Claudia.
Okay, thank you. Thank you, Daniel, for this presentation. Thank you for inviting me to participate in this defense. It's a very interesting work, comprehensive. Having said that, every human work is perfectible, so there are some criticisms that I have. Something that I would have liked is to have a more substantial introduction to put in context all the work, because there is a lot of work here, and I think it is not well put forward at its value in the introduction, where one would expect, I not one, but me, like a vision d'ensemble. You know, a more right now it is a list, a summary of what comes. And I was more than, so there is, and there are not, maybe there are not many references in the literature, but there is not the literature revision is meager, if existent at all. So that would have been good, and it's also gives to readers an indication of how much you have studied and you know of the problem.
Yeah.
That you know of the problem, because otherwise you wouldn't have done all that. But you are maybe it's also your style, that you are not extroverted and speaker. I don't know, but you have to advertise your all your work, and then there is a little bit that is missing there. But well, that's and for another thing that is missing is for all the implementations there is practically no detail of how it was done. It's there is very little detail for the cardinality constraints problem. I think you don't even say in which language it was implemented. It's important because it reveals and it shows all the volume of work that was put behind. Okay, in the part of the regarding the control problem, in the preliminaries or there is a mention of BOCOP, but I'm not sure where you use it, because nowhere it is explained. It is said you have all those results, but you have not told us how you put in place and you combine all those things. Okay, it would be good to have. So those are all the criticisms. Now come the questions. Okay.
Okay.
So regarding the cardinality constraints, it's a nice work. I would like to know if you can give us, I would like to ask if there is some physical interpretation for the facility location problem of the different models where the constraints, the cardinality constraints are decided in the upper level or the lower level or mixed. What would be the difference from the modeling point of view?
Okay. Yes, the principal difference is when in a mixed structure, we have this variable u. So with this variable u, you can interpret it like the leader will have more power or more freedom of decisions. So because this, for example, in this structure, you can see that the variable u is here. So this variable u will be a parameter for GNet. So that's it.
Yes. So, sorry, the phone is ringing here, but you are not calling me, no, Didier? It's not that. Okay. So, but what is U in the facility location problem?
Okay. U will be the decision for the leader.
That is what? It's where, how many of those plants to put where, the with percentage of plants to put, what is U?
For example, in one case,
I understand what is upper and lower level. What I want to know is the physical interpretation, you see?
Yeah. The physical interpretation that I see is, for example, the leader will be, okay, car 1, you go to the facility 1, car 2, you go to the facility 3. That is the decision for the leader program.
And then the follower will decide how much charge it puts in the station that was ordered to go and charge with. What is the decision of the follower then?
Yes, exactly. If the car go to one facility, so that car has to charge that energy, but probably the solution that appear in GNet, it's not feasible for the leader problem. So that is one reason that for this case, when didn't find any feasible point, is that for example, in this mixed structure, we found this different solution, but this solution is not probably this solution is not feasible for this case. So that is the reason.
Okay, thank you.
Okay, you're welcome.
Then I have another question regarding the pre-scenarios solution methodology. I don't know how to call it. So usually when you deal with a control problem that is infinite dimensional, there are two approaches. One is called optimize and discretize, and another one is discretize and optimize, right? So optimize and discretize, you first write the optimality conditions in infinite dimensions and then discretize there, and the other way, and the other is the other way. In which setting would you place this pre-scenario? Probably the second, right? It's discretize and optimize.
Yes, the second.
Yes. Okay, so in this setting, when you discretize and optimize, then there are, in all the concerns, in fact, when you solve infinite dimensional problems, you have to resort somehow to a finite dimensional setting. And then there is a question of what is the relation between the solution of your finite dimensional problem, the optimization problem, with respect to the infinite dimensional problem. For example, if you were doing some grid discretization, there has to be a proper relation so that when the step size or the grid size goes to 0, you do get a solution of the infinite dimensional problem. Have you thought of that? And have you observed some stability with respect to those pre-scenarios? Maybe how the solution depends on the output you get, depends on how you choose those pre-scenarios.
Okay.
It's okay to say that you didn't think of that. It's just it's a question that comes often. And so you tried only one set of pre-scenarios. That's the answer.
Let me think. Claudia, sorry, could you repeat the question?
Yes, the pre-scenarios that you chose, how did you choose different pre-scenarios, like configurations of pre-scenarios, or one set of pre-scenarios?
We consider the first one, fixing this specific
pre-scenarios. Okay, so my advice in that case would be to try a different set, maybe not too different, but a different, and look what happens. Is it stable or what happens? Because here it's as if you are replacing a continuous function by some step, a combination of some basis function, something like this, I would think it is. Then it may be very dependent, the solution, on this specific choice. It would be good to have some idea of the because it's important, this pre-scenario, to get all
Yes.
the outcome. And then my last comment and question is for this part of the economic interest of having some of those concentrated solar plants functioning and not needing to be helped by the government after 27 years. It's better than forever. Is there some indicator of risk that you could have introduced, or well, maybe in the future when you'll get some stochasticity? It's important to have risk. This is deterministic, and nothing is very deterministic here.
Yes.
Yeah.
Yes, for that last part, the idea is to have basis to address in the future the stochastic optimal control problem.
Okay, so that would be all from my side. Thank you.
Thank you. Thanks a lot to you.
Claudia, if I'm not wrong, thank you. So if I'm not wrong, Alejandro, you are here now in the room. So
Yes.
I let you continue the process.
Sorry,
so Claudia was the first.
Didier?
Yeah. You can give the microphone, the end microphone to Alejandro. Please.
Okay, now you hear?
No.
Hello.
Yeah, that's okay now.
Okay, so I was saying that, and sorry again for not be here from the beginning of this Tesis defense. Then I will then ask Olivier the round of question. Olivier, go ahead.
Thank you. And thanks for the invitation to this jury. It was a pleasure to read your manuscript, Daniel. I must say I was very impressed by the combination of what you did with, let's say, kind of state-of-the-art engineering issues, because you consider the typical problems we are facing, for example, at EDF, regarding electric vehicle charging stations, investments, or concentrated solar plants. But you combine these very current issues to state-of-the-art mathematical settings, even if, and I must confess, I'm not an expert, and I let the other people give you their impression about this part of your work. And for me, a perfect example of this to combine, because for sure there is nothing is magical. So you had to find some tricks like pre-scenarios to combine very difficult physical and practical problems and solve them. So this was the very positive part I found in your work. Also, you did a lot with different subsystems. For the CSP plants, you considered multiple storages, multiple economic indicators. And this is not always the case in the literature to have this comparative analysis of different systems, indicators. And it's very good for us as engineers. Another positive aspect that I found in your manuscript and again today is the global very good pedagogy, in particular to introduce the difficult settings you've been considering. Then, because there are always some drawbacks or aspects to be improved, I'm totally aligned with the first comment of Claudia about the global introduction. More about the applicative part of the introduction. According to me, it lacks some references, in particular about electric vehicles context, to make it clearer. And I will have a question just after about this. The context you want to consider and why is it very important, and in particular the question of charging station investment in this context. And maybe the other main drawback I found, and this is more related to the part 2 of your work, because you have very detailed modeling, in particular with the physical settings you consider, it's sometimes a bit difficult to extract some generic contributions or mathematical contributions because you have a lot of equations. It may be a bit ad hoc related to the very thin structure of your models. And at some points, I was a bit confused with this kind of big models. Okay, to come to the questions, first about the application of facility location problem with the cardinality constraints on the electric vehicle charging stations investment. I wanted to know, do you have any idea if your model could be applied, I mean, generically, whatever the charging context we want to consider for day after day charging during commuting patterns or for high-speed charging when people go to holidays, or is it specific to some context according to you? The models that you propose in your facility location problem?
Thank you, Olivier, for your question, but really, I have to see with more detail that question because for this first part, our model, it's just to illustrate these results, so it doesn't have a lot of details. So I have to see with more time and detail that question.
Okay, maybe to come because I have like 2 other questions, maybe more detailed and that are related to this point. The first one is about, if I understood correctly, you have a probabilistic decision from the users.
Yes.
So, but you have some concave functions. So if strictly concave optimization problem, normally you may have a unique optimal decision for a user. It was not totally clear for me why you choose probabilistic reactions or decisions from EV users.
Okay. What happens is for the structure of this problem, y is representing according our parameters if randomly the car go to one facility or another one. So we had some results when appear that one driver went to one facility with a specific probability and another one. So, but in most of cases, the driver, all the probability, it was to go just one facility.
Okay. Because to come back to my first question, possibly this probabilistic or not modeling of this setting may be relevant depending on the context, because if you think, for example, to high charging stations on highways when people want to go to holidays, for sure, you don't have a lot of choice to make it clear. So it may be deterministic choices that may be relevant in the model. So this may be related to my first question. Another question that I put in my report also, if I understood correctly, again, you have a kind of congestion effect model in the station because you have a maximal number of charge that can be done in a given day, the KS in your model.
Yes.
But for me, when we look at state-of-the-art demand response models, and you mentioned demand response in this part, it's more about the temporal scheduling of power. And typically the physical limits that we may have is some maximal power level at some time. Do you know how your setting could be related to the maybe more physical power limits that we face in reality? Because here it may be a bit abstract, only having a maximal number of charging operations for a day.
Yes. What happened is with that constraint, this problem will know with cardinality constraint. So if the constraint is the maximum of power, so that is another structure. So it will not it is not the case for this focus in this part.
I mean, I don't totally agree, because if you think, for example, to discrete charging levels, for example, a vehicle can charge, let's say, at 3 kilowatt. It may be discrete, and the number of electric vehicles charging at a given time may be limited by some number. So if I'm correct, you can come back to your setting with cardinality constraints, even if in a vectorial world of temporal charging profiles. Is it correct? Maybe I'm wrong, but having discrete charging levels and some power limit, the number of EV charging at a given time slot, is it can it be casted in your setting?
I'm not sure because for this model we are assuming that that all cars have the same capacity in each battery. So no.
Okay, maybe to be thought a little bit. I don't know. Yeah, but I mean, I think the model very original, at least because this kind of cardinality constraints, for me, it was the first time I found it in this kind of literature. So I wanted to say just maybe you have some slight improvements to be made to make this model even closer to reality. The one we try to model in places like EDF. Maybe coming to the second part of your work, and again, this is a kind of modeling assumption question. It's about a very standard assumption, but it's like at the beginning when you're discussing the spot market assumptions, you consider a price taker assumption, if I'm correct,
Yes,
and
correct.
that all offers of your CSP plant will be accepted. Can you just come back to this assumption? And maybe, I don't know, after having done a lot of simulations, have you observed some cases in which possibly it's not totally irrelevant, or is it always a posteriori justified?
Olivier, could you repeat the question, please?
Yeah. I wanted to say, globally, when you do the price taker assumption, it means some actor that you are currently modeling has not a big influence on the market. So you can do the assumption that the price is exogenous in your calculation, in your simulation. This is the assumption you did, but sometimes when doing the simulation, you can, after observing the results, having some doubt on this assumption. Just can you maybe just justify this assumption and why it may be totally valid in your case? Or did you get some surprising cases when doing the simulations? According to me, it may be related to the fact that you are simulating some individual asset. So
yeah, for this comparative study, consider different economical scenarios. So 3 different economical scenarios with critical economical scenarios, medium economical scenarios, and optimistic economical scenarios. So just for optimistic economical scenarios, it was possible to get results like this one, but for the others, it was not possible. So yes, at the beginning of this part, the idea with this study is to search or to see what extent the CSP plant can have a economical equilibrium without subsidies. So that's it.
Okay, thanks. And maybe my last question, and it's interesting because it's coming back to one point mentioned by Claudia, but maybe with some other view. It's about your pre-scenario modeling. So you have constant rate pre-scenarios. Do you have some idea about how you could enrich this kind of scenarios or of pre-scenarios? And have you tested the sensitivity of your results about with respect to this assumption? I don't know if you made these pre-scenarios quadratic or I don't know some parameterized family. Is it relevant? Do you think would it be tractable? And have you did you do some tests to assess how this assumption is very important regarding the results you obtained?
Okay. To choose this scenario, the main reason is that they this correspond to the a real situation, because during the day we will have just one storage system, so it doesn't make sense to consider 2 storage systems because we will you will turn off the power block, so you will obtain a cost to do that. So that's it. So during the day, we consider just one storage system, and if we have enough energy, we can produce electrical energy at the same time. And also, this pre-scenario was because we are implementing this production strategy that is price chasing. So the idea is to see this flexibility to consider this production strategy, because as this problem is deterministic, we know where is these peaks on the electricity market prices, so we can discharge this energy in the best moment.
Yes, but I mean, then even if deterministic in some cases, if constrained to constant rate profiles, it may be costly compared to very free profiles that may allow you to do some bigger benefits, no? To have access to all the profiles you want may lead to some better performance for your system in general, no?
Yes, but it depends of many things. For example, the production strategy, because also we consider classical strategy. So in that case, we don't have this effect with respect to the price curve.
Okay. And maybe related to that, it will be my last word, but I don't know if I understood you have the possibility with pre-scenarios to jointly optimize investments and dispatch of your CSP plants. But after having your decisions, you could imagine testing how much regret you may have to have considered constant pre-scenarios, fixing the investments at the values you obtained, but making the dispatch decisions more flexible. I mean, not necessarily constant. Have you tested this kind of engineer tricks, I would say, to a posteriori assess how much the constant assumption may be costly in your modeling?
Yes, could be an interesting result, but I didn't do that.
Okay. Thank you. This was my last question.
Thank you very much, Olivier, for your questions, and Daniel for the answers. Then I will now to move to the next member of the jury, Pierre. Your remark and questions. Go ahead.
Yes. Do you hear me? Yeah.
Yes.
Okay. Thank you for your interesting talk about the manuscript. So it was very interesting. I have sometimes some difficulties to follow your ideas, and an important thing I think is that there is no nomenclature. So for people who are not so aware with your subject, sometimes it's difficult to fully understand the meaning of your notations and variables. But in general, okay, I had the chance to follow you during the follow how the CSC, how we do. I don't know the name in English.
Follow-up committee. Follow-up committee.
Okay, follow-up committee. So I was I know a little what you were doing, and I think that it's so the first thing I want to say is that when I saw the journey you ran during these 3 years, is quite impressive, and congrats for that, because you provide a very lot of work and in general good job. But I have some questions, and I will come back about so maybe it's candid question for people who are not so good in mathematics, but I have not fully understood the cardinality problem. I think because Olivier speak about that. So could you come back to, I think it's slide 15 or 16? I didn't. So maybe I understood now. So first, for example, there is no nomenclature. So I don't understand what means the dot after the y. In your cardinality constraint, you have y and a dot.
Okay.
What means this dot? It's
okay.
Maybe a stupid question.
Okay, yes, K is representing the maximum capacity for each facility. So S is representing a facility, so Y point is the different drivers that they can go to S. So of all these of the components, okay, you can see this Y like a vector, and Y point is each component. So this line represents that the zero norm. So it's lower than Ks.
Yeah. So it's clear. So, but okay, I think I understood that when you answered to Olivier, but because in the manuscript you said that it is a probability, and for me a probability, it's a probability law. But in fact, it is a solution. It is part of your solution, of your optimal solution. The y. The y is calculated by the algorithm.
Yes.
Yes. Okay. Oh, it's clear. Thank you. And I did not understood also. You define 4 objective function: profit, welfare, and mixed profit and mixed welfare. So now maybe I have understood also, but it is not clearly defined in your manuscript. So maybe it's clear for mathematician, but for physicists it's quite difficult to understand. So what do you mean by mixed? It is related to the cardinality constraints also?
Yeah. What mean mixed structure? That is your question, right?
Yes. So you have 2 objective functions, which is quite clear. It's profit or welfare. So it is clear. But when you present the results, you speak about upper profit, upper welfare, and mixed profit and mixed welfare. So upper profit and upper, I understand that, but mixed. What do you mean by mixed? I did not got it. I did not understand.
Okay. Upper. When I say upper structure is when we have one structure like this one. Yeah. So, but when I say mixed structure is when we have one structure of bilevel optimization problem like this one. So this equivalent way that we can write the zero norm is distributed in both levels. So at the moment that we solve these problems, we have the first structure with profit and social welfare, and also we have this structure for mix, maximizing profit and maximizing social welfare, because remember that for upper structure, practically you have all this red expression in leader problem. But for mixed structure, this expression is like this problem. So here I put just a formulation for a facility location problem with cardinality constraint at the upper level. But yes, it's missing the mixed structure, but here is just for the upper structure, because here we have the cardinality constraint. It's clear or no?
It's almost clear, but I will discuss with Didier. It is quite
okay. Sorry,
difficult for me, but okay. So I understand the at least the method. You on the I think it's maybe the following slides. You speak about the gap, and it's a figure in your manuscript, page 50. Yes, the gap. So what is the gap? How do you define it?
A gap is the distance between the optimal solution of a primal problem and a dual problem. So the distance of the solution in this problem is the optimality gap. So optimality gap will be equal to 0 when this solution in these problems is the same, of the distance of this solution is 0.
Okay. No, it's not so clear now for me, but Okay. Yes, and about, so you simulate 50 scenarios, and so could you speak about, so you show the results, but I think that you, as far I have understood, you have a initialization process. I don't know how to call it, in which you put some randomness about the position of the car and the number of the car. I'm right, or what is the difference between the 50 scenarios?
Okay. Yes, for this simulation, we consider 50 different cases. So for each case, we have alpha and p different parameters because we are.
And they are defined randomly. I'm right?
Exactly. So for each case, we will have that the preferences of the driver are different. The congestion in each facility is different. So according to these values, is that we found this result.
Okay. I think you don't. I think this point is very important for me, and maybe you should emphasize it a little bit more, because it's not when in your in the manuscript you speak about it, but I think it's an important point. Okay.
Okay.
So now I will, if I have still some time, on the second part. So it's slide 24, I think, page 65, 54. Yes, you speak about polynomial regressions for the ranking scheme modeling, and in the manuscript you present some there is a lot of there is several one, and there is several parameters to fit for a model, but you said you speak about some, but I did not get if you make the fit or if you take the value of the coefficients from some.
Yes, that's correct. To define this polynomial regression, we use SUN2 because for the solar field component, also we use SUN.
Yes, but the coefficient you input in your correlations. What my question is, how you proceed? You have the polynomial regressions in SUM, or you fit some polynomial regressions from results given by SUM?
The second one, according to the.
Okay.
Yes.
Okay, well, it's because it's not clear in your manuscript, so now it's clear.
Okay.
Little mistake, page 66 of your manuscript. There is this is a detailed point, but I think you have to correct in your manuscript. Equation 425. So this is the phase change of water. And you speak about synthesis and decomposition, and I think that you would better speak about condensation and evaporation. It would be more correct. I think you did a cat copy. Maybe you understand what I mean? You have H2O gas, which give H2O liquid. And it is it is named synthesis and decomposition, which is correct for the solid gas reaction, but for the liquid gas equilibrium, we not speak about, you don't synthesize anything, it's water. So it's just water vaporization and water condensation. Okay?
Okay.
But I think Didier, you understood, Didier? You understand? Okay. Yeah. I have some time, still some time. I have two little questions more.
Okay.
Yes, go
Yeah.
ahead. The last two little questions,
Okay.
as you say.
Right. So it's, I was surprised by the value. So it's slide 30. It's about the LCOE. No, so maybe the one before. Yes, you have LCOE of about 5, or let's say, well, above, no, under 10 cents per kilowatt hour. And if you, so it's very low, so it's very good, it's very low, but there is a recent publication about CSP, which is based on, we have a lot of data, big data set collected by Solar Tesis organization, and I have it on my other screen, the better LCOE, which is announced, so it's commercial one, it's about 20 cents. So I'm quite surprising by your results, but it's very low. And if your calculation is correct, you will win the jackpot, I think, because it's very, very, very good, very good. But maybe check and comment with this data set. I can send you the reference of the publication.
Okay, thank you.
And I have, so now the last one is about the investment costs. So as far as I understood, you fix the capacity of the power block, the Rankine cycle.
Yes.
And because you make vary, you or the optimization algorithm make vary the storage capacity. And the investment costs related to the solar field is estimated through solar multiplier indicators. And so these solar multipliers is given by your algorithm also, or how do you determine it?
Also, we consider different solar multiplier, but for this case, the solar multiplier it's equal to 2.5, and it was estimated by Sun.
So it's constant?
Yes, it's constant.
So there is sometimes I don't understand, because normally, if you make the storage capacity vary, you make vary the. I did not. You present some figures about that. You make vary the storage duration, and if you increase the storage duration, there is two consequences. First, for the same solar field, you would you would make vary the gross capacity of the Rankine cycle, or at fixed gross capacity of the Rankine cycle, the solar field have to vary it. So I don't understand how you proceed. You treat this. Do you understand? I mean, if you have more, if you increase the storage capacity, it means, and if you have a constant solar field, You say that the capacity of the Rankine cycle is constant and the solar multiplier is constant. So this implies that the solar field is constant. Okay.
Okay.
And normally, if you increase the storage capacity for the same input power as your solar field is constant, for the same heat input during day, you will get a smaller capacity because the same amount of energy has to be released in a longer time. So maybe I make a mistake, but okay.
Yeah.
You understand what I mean?
Yes, yes. I am
maybe
thinking.
Some figure. No. Okay. Okay, so maybe this could be an interesting point to develop in the next thesis.
Yes.
So thank
yes.
you thank you for your answer, and still again congrats for your presentation. It was very interesting, and thanks to Didier to invite me to this defense. Okay,
thank you.
Finished.
Thank you for your question.
Thank you, Pierre, for your questions. Now is the time for Freddy, who is here with us. Go ahead, your question or remarks.
Hi, everybody. Thank you for the University of Perpignan in Chile to invite me to this defense. Thank you, Daniel, for the presentation. It was very interesting to read and see your presentation. Was for me coming from the physics part of the concentration solar power was a little difficult to understand a lot of things in the mathematical procedure. But at the end, I think I have a whole idea of the work, and for me it was very interesting. I have a few questions. First, I think in accord with Claudia, I think the work may be perfectible. I think there is a lack in the connection with the physical reality. Sometimes was difficult to me understand the meaning of some assumptions or things in the simulations. So I think that there is maybe it's perfectible this kind of connection with physical reality. And also in accord with Pierre, there is many variables that are difficult to follow in the mathematical procedure, because sometimes there are some nomenclature after that appear another one, etc. That was difficult to follow. So I have some questions. The first part, I didn't understand very well that the meaning of the gamma. I think it's the same question here, and because if I well understood, the upper problem, the lower problem, and the mixed problem is the same problem modified in order to find solutions.
No, in order to find solution, is the mix. Oh, sorry, the mix structure. It was a proposed to address the case 2, because for the case 2 we have that these red expressions are in each follower problem, right? So,
Okay.
but what is the problem? That the dependence of variable u also will be in each follower problem. So the feasible set of each follower problem will be no convex. So to demonstrate the existence of solution for that case, it's no easy. So one solution for that is, okay, we have this reformulation of the zero norm, so we can put this expression here in the leader problem, but the dependence to, in that way, the feasible set of each follower problem, so now will be convex.
Okay, but it's a reformulation.
Yes.
That means that it's the same problem, but reformulated.
Yes, yes.
So see, if it is true, I surprised from the results, because the results are different. So or one result is the global optimum, and the other one is partial, is not partial, local optimums, or I don't know. Can you explain me that?
Yeah. Okay. According to these results, in this structure, in particular for this structure, it was not possible to find in all cases a feasible point. Why feasible points? Because according to the optimality gap, it's not necessarily the optimal global solution for that problem. So, but for the mixed structure, according to the optimality gap, that corresponds an optimal solution for those cases. But my comment in this part was that for the upper level, probably it's necessary more time to find an optimal solution or a feasible point or optimal solution for that structure. But it's just to show you the behavior for this structure, because for the mixed problem, in all cases, the behavior was very, very different.
Okay. If I well understand, the gap is the distance from the optimal, the global optimal.
When you have a optimization problem, you have the primal problem and the dual problem. Yes.
Mm-hmm.
So you will have a optimal solution when this gap is equal to 0. It's like a measure the optimal solution for that.
So what is the reference to say this is the optimal, the global optimal?
What is the reference?
The reference. How do you find the global?
According to this result, a system of results. According to this one, we can guarantee the global solution for this problem.
Oh, okay. It's a little hard to me to understand. Okay. I will pass to another question. This is I want to understand. No, I want. Can you imagine how to measure? In this case, P and alpha in a real case, because for all simulations, alpha and P were randomly choose.
Yeah.
But in reality, that is very difficult to understand how to measure. For example, the people can go to one station or another station. How can you imagine how to conduct this kind of experiments or measurements?
Yes. For example, P, we determine this parameter according to the distance of each driver to facilities. So according to the distance, we will have the preference to go to one facility or another one. And alpha is the congestion factor. So the idea with this parameter is So if we have a high value for alpha, the driver doesn't want to go to this facility because we will have like more weight for that particular facility. So that is the interpretation.
Yeah, but how to you can estimate the real value?
No.
It's just an exercise of imagination of
Yes. No, at the moment, the idea is just to have a illustration for this structure that we found. So we don't have a lot of details for these parameters according to the reality.
Okay. Another question I have about the CSP problem. You use pre-SNR. First, you use results of SAM to have a correlation between the irradiation and heat production, if I well understood, in the solar field. But in the results, I understood that all the profiles of DNI are clear sky, like this, just like this, clear sky. So the results that you shown for the CSP problem maybe vary a lot if you use a real DNI profile. So you measure something, or you take into account some of these variations?
Really, there is another problem, because for this work, we are assuming that we have a perfect day in all of the year, but also we consider to estimate this function the different station in the year, but we don't have variation like I showed in this case.
In the last part. Yes. The question is the formulation of the optimization may remain useful or available with a DNI profile changing all the time, or maybe there is is necessary another reformulation for the optimization.
Your question is?
I mean, the formulation of the problem, the mathematical problem for this case, when the DNI profile is perfect, is this one that you present.
Yeah.
If the DNI profile is very sharper, it's possible that the formulation of the optimization model maybe doesn't work. I don't know. It's a mathematical question. I don't know the answer.
Okay. That is another problem, because in that case, okay, for one way, we can have stochastic variation. So if this variation are deterministic, yes, it's possible to consider, but maybe it's necessary to see more details, because, for example, to determine this curve, what we did is to consider mean profiles, because this is the mean of all points that we generated in for example, in one station. So at the end, we will have one curve like this one, because it's the mean value of this point.
Okay. Okay. Last question. I think I don't have much more time. For the last part, chapter 6, You consider, if I well understood, you consider a big storage because with some perturbation, you have only one stop in the ranking cycle. That means that you have enough storage for that. What if your storage is variable, is lower regarding the power? Yeah.
Sorry, when you say big storage,
I don't know because you have all the day,
yeah,
24 hours, the ranking cycle working, and you stop just 20 minutes. So to face this one with a solar facility, you need a big storage.
Okay.
So
Your question is?
in the case when you have a clear sky model for the DNI, it's clear that you can't put a big storage with a low price, but with a DNI profile different. If you want to have a ranking cycle working all the day, you need a very big storage that it's very expensive. So for me, that's not clear here that you work all day at maximum power. So I think if the storage is smaller, maybe the answers are different. I don't know. It's just a reflection. I don't know if you have some answers for that.
Yes. Okay. For this case, it's clear that we consider critical scenarios. So also, we have a limit to store energy because according to the dimension that we consider for this part, always if we have a perturbation, so it is not possible to produce electrical energy because we have nominal values to produce electrical energy. So with just one perturbation, it's enough to turn off the ranking cycle because it's not possible to produce electrical energy.
Okay, I understand that. Yeah, that's okay. Just one more, please. How difficult you see to connect the model developed in chapter 5 and the model developed in chapter 6? That at the end, I think is the next part of the work.
Yeah. Yes, of course. This is a reduction of the first model. So, for example, yes, the connection is we can't deduce this component and this one because for this one we are considering an exogenous function. So, according to this value, it's possible to define these expressions. But for the two tanks storage system, it's similar that we consider in the first part, but in this case we have this system is in series, but the another one it was in parallel. So that's it. I don't know if
Yeah, I understand you need to accommodate some.
Yes, simplify some expressions.
Okay,
but
it's not very hard.
Exactly. Okay, maybe it's not anymore, but yes, it's noisy. Okay, thank you.
Thank you, Freddy, for the questions. Then now is the time for the Natalie as a invited member of the jury. Go ahead, Natalie.
Hello. Thank you for you understand me?
You were?
Yes,
Me?
yes.
It's okay?
Hello,
Okay.
Natalie.
So thank you. Hello, Daniel. First, I would like to thank you for this nice presentation. It was quite clear and good, with a nice structure. And I am a part of this job, a part of this supervising of the job, a little part. So I'm happy to see that the result of this work, and because it began by collaboration between mathematical researcher and physicists. And it was a bit difficult at the beginning to understand each other. So we have a lot of work, and it began by an efficient pair of two young researchers. One of them was David, and the other was Émeric Tapaches, which was on the thermodynamic part. So we have done a lot of job in this first part, and then when Daniel arrived, he has to understand and to get all the information which have been already done, and to also to understand all the physical problem under this model. So I think he has, and he was alone to do that. So he has done a very a large effort to do that. So I think that some of the questions from the previous members of the jury were related to choice or to decision which have been made in the first part of the job. That means before Daniel arrived. So it's perhaps why Daniel was sometimes a bit not very clear. And for example, for the question of, from Pierre, which was more or less how can we manage to have a fixed solar field, a fixed Rankine cycle, and a storage which change. It was a decision we made it at the beginning of the work. We decided to have the question was what can we do with a given solar plant? That means with a given solar field and a given Rankine cycle, and how can we manage in the more efficient way a storage between them. So we decided to fix both, but we allow the model to defocus the solar field, so to have less solar input, and also to operate the Rankine cycle under its nominal power. So it was a decision to simplify and to focus the attention of the way to size and to manage a storage system. So it's just a comment for that. So I have I have even one question for Daniel, one generic question. We have during this work done several simplification to be able to solve the mathematical model, because there were a lot of variables, a lot of things. It was quite difficult. And I think Olivier in his report says that there is some assumption about the losses which are not discussed. There is also some assumption about the power which were constant, the constant profile in each step. So so my question is do you think it will be difficult to add, for example, a variable power of the Rankine of the thermochemical reactor, or is it a question of computing time, or is it a question of mathematical methodology difficulties if we want to add this better representation of the thermochemical reactor? I don't know if my question is very clear.
Okay, Natalie. Okay, could you reduce a little bit the question?
Oh, yeah. So my question is, we have simplified a lot of things. One thing we have simplified is we said that the chemical reactor operate with a constant power. Can we modelize the reactor in a more realistic way by introducing a variable power produced by the reactor? Because you know that at
the end of the reaction, the kinetics decrease. So is it possible to introduce with the same, or where is the difficulty if you want to introduce a variable power of the thermochemical reactor? Is it a question of time of number of variables, or of time of computational time, or number of variable, or is it a question of adding a new function? Do you have an idea?
Let me think.
But perhaps you can not have an idea about that. So I have another improvement I can suggest. We have discussed, and you have also put it in the perspective. It's a long-term storage. That means a storage larger than a week. That means that the pre-scenario have to change. So is it change? Is it a complicated change? That means it is a new methodology, or it is simply increasing the number of variables?
Okay.
If we want to go to long-term, to simulate long-term storage.
Yes, maybe it's not direct because, for example, at the moment that we model this new strategy, it's necessary to have realistic data. So at the moment, for example, thermochemical reactor system, it's like an experiment, but this kind of storage system is not implementing in the company or industrial company. So it's possible to model that, but of realistic results maybe is not possible yet. So that's it. But at the moment, thermochemical reactor system, it's a good purpose to store energy for long time.
Yes, but you think you will be, we will be able in the future to simulate it quickly, or it is really a big challenge?
Medium.
Medium challenge. Okay, so it's possible. Okay, so I know this work, so I don't have any more questions. So I want also to congratulate Daniel to be involved with this work and to have achieved this result and this nice work and this paper, also the paper. Thank you.
Thank you, Nathalie.
Thank you, Nathalie, for your questions and remarks. Now it's for moving to the advisor. We have going to start with Hector first, and then Didier, and then David. Go ahead, Hector.
Thank you, Alejandro. Do you listen to me? It's okay? Okay, thank you.
Yeah.
You have done a lot of important work of modeling, and then numerical simulations and numerical schemes.
Hector, I don't know.
Yes?
I don't know if it was the case for everybody, but for me, you were frozen at the beginning of your speech. Could you repeat the beginning of your speech?
Okay. So I'm going to talk about the second part. Regarding that part, your work was devoted more
modeling, right? Actually, you make a big work on modeling, many different problems, scenarios, and we discussed a lot about that. And then those problems were solved by some numerical scheme, right? BOCOP or some discretization, etc. But during your thesis, we have discussed actually quite a lot about some theoretical approaches to say something about those models, right? In particular, with the hope to say some qualitative, obtain some qualitative results that somehow help to solve them either analytically or numerically, right?
Yeah.
So somehow I miss a little bit that part in your talk and thesis. I can understand that it were not finished results, but maybe you can say to the audience and to the jury, what were the main difficulties you faced from the theoretical point of view? What are the challenges that you have, let's say, faced during your work from the theoretical point of view in the second part?
Okay.
Mhm.
Yes, for this part, the idea was to guarantee existence of solutions for this model considering switch control variables. So there is a long way to demonstrate this one. So the first part is demonstrate that the dynamic is convex. So to do that, one way is to I don't know. Let's see. Okay, to consider this variable, this variable is like a binary, 0 and 1. So the idea is to consider this variable like continuous. Yes, relax.
Relax is the word you're lacking. Relax.
Thank you. Yes. So probably, yes, that is the way to demonstrate one solution for this problem. So after to relax this variable, the idea is to prove the equivalence between these problems. So in that way, we will have an existence of this solution for this problem. So that's it, but that part is missing.
The stochastic approach, right? Of course, that was by far more challenging. Maybe we were too optimistic at the beginning of your thesis. But again, can you say something general about what are the main difficulties to deal to incorporate uncertainties here in the problem, and then to work with stochastic optimal control?
At the moment, it's not easy to answer that question because really we didn't see any details with the two stochastic variables. Yes, at the moment, we know that this variable is this variable will represent the uncertainties on this curve. So maybe we need to address more literature with respect to this kind of problem, because the techniques that we use for this part, for the deterministic part, to find us optimal solution, probably it will not work for the stochastic problem.
Thank you, Hector. We move to Didier, go ahead, Didier.
Yeah, thanks a lot. So well, of course I will not ask question because we asked so many to already to Daniel during those 3 years. But I would like to give you some idea about the context or the general context of the thesis that probably you don't know. First, I would like to say that in his first year of thesis, actually Daniel was fully in COVID situation, which means totally isolated and doing initial job of the thesis by distance. So even distance with Chile. So that was not a comfortable situation. Another thing that has been kind of important in this thesis, and it has been enlightened by some of you, in particular Olivier, is that even if the title of this thesis is applied math, actually it is at the frontier of engineering, and even more in the frontier, but sometime in the interior of the set of engineering, which means that it is a situation in which you have to combine math and engineering and to be performant in both, which is really a challenge. And another challenge that was clear in this thesis is that it is a co-tutel. And he had at least 4 collaborators, Hector, David, and I, but also Natalie. And working with so many collaborators, additionally to two other ones from Chile, Jose Cardemil and the other one. So it's kind of difficult also to collaborate with so many people. And as Natalie said, there was also a context is that at the initial part on the CSP section of the manuscript and of the work, Daniel has to rebound on another work that has been done on CSP and optimality on CSP, and a job that has been done by 2 postdocs at the same time, so a huge work, and he has to embrace this quite rapidly to be able to rebound and to create and to innovate above this context. So that is a bit of context for the PhD of Daniel, for you to measure the difficulty he faced during this PhD. And thank you, Daniel, for the presentation and for working with me.
Thank you, Didier. Thank you so much.
For your remarks, then now it's time for David. David.
Well, I won't ask any question either. I just want to say that this has been a really challenging work. It has 3 parts. Each part was coded in a different language. In fact, the first one was coded in Julia plus Gurobi, the second one in MATLAB, and the third one with Bokop. So at each time we ask you to go to some new place, to manage a new tool, to get involved with new things, and you succeeded a lot. I want to say this is the fruit of your work, and it wasn't easy at the beginning, as Hector said. We might be a little ambitious, but when we were into the problem, we realized that there was a lot of difficulties, as research is. I mean, this is the game that we didn't take into account, and you managed to solve them. So you have to be proud, and it's been a nice path. I'm very happy with the results. I'm very proud of you. So yeah, for me it's just congratulations, and I really there is a lot of perspectives, a lot of things that we could have done better, a lot of things that have to be done, but you can see the committee really involved, asking very hard questions, because it's an interesting topic and it's a difficult topic, and you manage to do contributions in difficult topics. I think this is what makes me the proudest. So thank you. Thank you for this lovely presentation. It was very clear. I'm very happy with it.
Thanks a lot, David.
Okay, then thank you, David, for your remarks. Then I think the jury in France and here in Chile cover most of the points that which are developed in the thesis. Of course, this thesis is very wide in the sense of topic that touch, and then for my understanding is this is that close some questions but open many, and then and then I agree with the remark that Claudia did at the beginning. Is one of the missing point, important missing point is uncertainty. The stochasticity so far is poor, but there are of course many challenges, and in particular, for example, you think that in CSP. One of the countries that most investing in CSP today is China. Why? Because they are using CSP for the stabilization of the system for the massive entry of renewable, wind, and solar, and so on. So that is very important questions. It's not addressed in this thesis, but some of the tools that Daniel developed in the thesis could be interesting to face to trying to understand better this kind of questions. So this is my point of view. I'm not going to ask more questions because as I said, you as a member cover most of the point. And then now it's time for the deliberation. And then we are going to use this room for deliberation. So I'm going to ask the audience to go out for a moment, and then I will tell you when we are ready. So I'm going to then put your microphone, David.
For the people in the Teams, Didier, you will create a new room. That was
Actually, I created a new room, but we can try if you want to connect to a new room. I'm not so sure because I used to use Zoom and not so often Teams, but I created a new one and I can send you the contact if you want. Do you want to swap to another one? Better?
I think it's better because there are a lot of guests in this room.
So I will immediately send you a new link and please try.
Okay.
I'm not so sure about the result, but if not, then we reconnect to this one, okay?
Yes,
Okay.
please. So for the people in the guest room, we will just turn off the microphone so you won't listen the deliberation.
On attend toujours, non?
Oui, le mail n'est pas arrivé. Oui.
D'accord.
Ouais, moi je viens de le recevoir. Ouais,
Je ne vais pas pouvoir me connecter sur Teams parce qu'il demande un compte. Je n'en ai pas.
Marché. Alors les gens, si vous pouvez, on va fermer on va faire sortir les invités. We are going to make the guests to go out this room, and then you can reconnect. So I'm sorry, but we need to deliberate. So.
Entonces nos quedamos acá.
Sí, quedémonos acá nomás. La gente que está de invitado, por favor, si puede salir porque no pudimos abrir la otra sesión. Eso. Así que vamos a tener que pedirles que salgan de esta sala y se vuelvan a conectar en un rato. Pueden intentar conectarse desde ya, yo los voy a aceptar solo cuando esté listo. Ok.
Todavía hay 10 conectados.
Me, my Estoy llorando en mi habitación. Todo se nubla a mi alrededor. Ella se fue con un niño pijo. Tiene un Ford Fiesta blanco y un jersey amarillo. Por el parque les veo pasar. Cuando se besan lo paso fatal. Voy a vengarme de ese marica. Voy a llenarle el cuello de polvos pica pica.
Hola, ¿me escuchas? Hola, dame una señal.
Bernie, ¿qué haces?
Jake, necesito comunicarme con los niños de la casa.
¿Quieres contarles que los esperamos en AJ? Hecho para niños curiosos. Los esperamos en
¿Te gusta la experiencia gratuita de Spotify? Siempre puedes explorar nuevas formas de disfrutar y lugares donde escuchar tu música. Con Spotify Premium podrás descubrir cómo descargar música para escuchar en modo offline y desactivar o activar el modo aleatorio según tu estado de ánimo.
lugar de un gran país. Olvidaron construir un hogar donde no queme el sol y al nacer no haya que morir. Y en la sombra mueren genios sin saber de su magia concedida sin pedirlo mucho tiempo antes de nacer. No hay camino que llegue hasta aquí y luego pretenda salir con el fuego de el atardecer. Arde la hierba. En algún lugar de un gran país olvidaron construir un hogar donde no queme el sol y al nacer no haya que morir. Un silbido cruza el pueblo y se ve un jinete que se marcha con el viento mientras grita que no va a volver. Y la tierra aquí es de otro color, el polvo no te deja ver. Los hombres ya no saben si lo son, pero lo quieren creer. Las madres que ya no saben llorar ven a sus hijos partir. La tristeza aquí no tiene lugar cuando lo triste es vivir. Na 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 me quieren agitar, me incitan a gritar. Soy como una roca, palabras no me tocan. Adentro hay un volcán que pronto va a estallar. Yo quiero estar tranquilo. Es mi situación, una desolación. Soy como un lamento, lamento boliviano que un día empezó y no va a terminar. Ya nadie hace daño
reggaetón y perreo, la playlist de los éxitos urbanos del momento. Escúchala, guárdala y compártela aquí en Spotify.
Te olvidaste de mí y de mí y de mí. No supe qué día te olvidaste de mí y de mí y yo de ti.
Flaca, no me claves tus puñales por la espalda tan profundo. No me duelen, no me hacen mal. Lejos, en el centro de la tierra, las raíces del amor, donde estaban, quedarán. Entre no me olvides, me dejé nuestros abriles olvidados en el fondo del placar del cuarto de invitados. Eran tiempos dorados, un pasado mejor. Aunque casi me equivoco y te digo poco a poco, no me mientas, no me digas la verdad, no te quedes callada, no levantes la voz, ni me pidas perdón. Aunque casi te confieso que también he sido un perro compañero, un perro ideal que aprendió mal a ir y a volver al hogar para poder comer. Flaca, no me claves tus puñales por la espalda tan profundo. No me duelen, no me hacen mal.
alegrías del corazón. Y no me digas, pobre, por ir viajando así. No ves que estoy contento, no ves que voy feliz. Doce y media en la mañana, el olor se mete en la ventana. Son flores y mil animales que me dicen bienvenido al sur. Yo recuerdo a mi papito y no me importa estar solito, porque me llevan a las tierras donde al fin podré de nuevo respirar adentro y hondo, alegrías del corazón. Respirar adentro y hondo, alegrías del corazón. Y no me digas, pobre, por ir viajando así. No ves que estoy contento, no ves que voy feliz viajando en este tren al sur. Y no me digas, pobre, por ir viajando así. No ves que estoy contento, no ves que voy feliz viajando en este tren al Tren al sur, 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 tren al sur.
dans le texte, c'est pratiquer, c'est pas praquer. Il y a une petite faute d'orthographe.
Ah, ok. Bon,
J'espère qu'il va bien comprendre.
Les gens sont là-dedans, les invités. Alors. Puedes pasar con la gente que te vino a ver.
Vous allez pouvoir reconnecter les gens à distance? Ou pas? J'ai vu qu'il y avait de la famille de...
Ils sont dans la file d'attente, non?
Ah, d'accord.
Y le tienes que preguntar si quieres leer el juramento hipocrático, que puedes decir que sí o que no es optativo. Si quieres leer este texto que es el juramento hipocrático en francés, y puedes decir no, si no quieres.
Then after some time of, I'm going to put here, then they can see the jury online. So after some time of the deliberation process, we are fully agree, all the members of the jury fully agree to the main decision. Remember that we have here in the Chilean and French system. For the Chilean system, your thesis was by unanimity full approved. That means that you are now PhD and then in our system. And from the French side, there are two steps. Then first, we need to ask if you want to read this French statement about the thesis. It's in French. Okay. Okay, so it's complicated. But then I would like now to read what the procès-verbal, what the report of the member of the jury think about the thesis and the defense of the thesis, your presentation. So, Mr. Daniel Lasluisa defended his PhD thesis entitled Contribution to Optimization and Energy from BILEVEL Optimization to Optimal Design of Renewable Energy Plant during 45 minutes. His presentation was clear, didactic, and pedagogical, and much appreciated by the jury. The jury noted that his work was very interesting and timely. He overpassed the difficult challenge to combine applied mathematics and engineering problems, acquiring these two skills at the high level. Through his presentation, the jury was able to acknowledge the candidate expertise on both topics, energy system analysis and BILEVEL optimization method. The presentation was followed by a rich discussion, including many questions from the jury concerning both fields, mathematics and engineering. The jury appreciated the candidate's skill to combine successfully mathematical modeling and with advanced engineering tools through different collaboration with both the academic and the industry worlds. The jury wishes to underline the quality of and the quantity of the work accomplished by the candidate. Consequently, the member of the jury proposed unanimously and after deliberation that Mr. Daniel Lasluisa should be awarded the degree of Doctor of the University of Perpignan via Domitia. The member of the jury also expressed their warm congratulations to the candidate. So, and from Chile, congratulations from Chile, from France, and from Brazil. So now, did you want to say something?
Okay, thank you so much, the jury, friends, family. Thanks to you to be with me in all this process. So my advisor, Héctor Ramírez, Didier Ocel, and David Salas, thank you so much. You are an excellent mentors for me. So thanks a lot. And and that's it. Really, in this moment, I don't have a lot of work for my I have a lot of nervous, so that's it. Thank you.
Thank you,
Thank you,
Daniel.
Daniel.
Congratulations.
Yeah, thank you, Daniel.
Very good.
One as a member of the as a president of the jury, would like to transmit also that one of the remarks that were very important made by the jury. So these remarks and some of the answers you can add in the final version of the decision, right? Okay, this is something that part of your work after today. And then again, congratulations and thank you very much to the member of the jury from France, Brazil, Chile, and
Thank you for that.
bye-bye. Bye-bye.
Thank you, Didier. Thank you, Daniel. Bye-bye.
We are the champions of the world. I've taken my bows and my curtain calls. You brought me fame and fortune and everything that goes with it. I thank you all, but it's been no bed of roses.